Thank you. Thanks for coming to my talk. My talk is about effective debugging in Ruby. And let's have a quick overview. My name is Jonathan Wallace, and I'm happy to be here. It's my first time in India. So a quick overview. We're gonna walk through a case study, look at some basic commands in a debugging Ruby library. We'll recap what we've covered, look at some more advanced commands, and then we'll look at the debugging libraries that are available in Ruby and talk about which one you should use based on your current situation. So let's look at our case study. Here's the situation. You've been handed a new project by your boss. This is a project that already exists, but it's new to you. And this project is covering a specific domain. It's covering a parasitic relationship between a crab and this parasite called Sacculina carcini. This parasite is extremely interesting. It's very fascinating. It actually infects the crab and takes over the crab's life cycle. The crab no longer reproduces. The crab no longer grows. It continues to eat and forage for food, but all its behaviors are modified such that it reproduces the parasite. Even more interesting, it infects not just female crabs that reproduce, but it also infects male crabs. The male crabs undergo a physical transformation to change their shape, and they become more female-like in their shape, and then they also act like a female to reproduce and help the parasite reproduce. So it's super interesting. Our project, our Ruby code, is modeling this domain. So we've got this project that our boss has handed to us. And we have a test suite. This is a plus. I'm very excited. This implies good things about the code that we're going to work with. And the other developer who has handed the project over to us says everything's good to go. You can dive right in and start developing code. So let's test out and see if this developer is saying is true. So we run our test suite and we find out, there's actually an error that's occurring, which it's good it's in the test suite. The test suite is covering this error, but that's unfortunate. So we need to figure out what's going on. We're going to look at this error specifically. And it's important to know what your error message is if you're going to try to determine the root cause. In this case, we are expecting a value and we're receiving a nil. This value in this case, if you're unable to read the slides, we're expecting an instance of a Sacculina carcini, which is the parasite. And if we look a little further in our test failure message, we can see a stack trace that explains where this error is occurring in our test suite. Now, traditionally, I might not go in this direction, but I want to make sure that we're using our tools effectively, and we allow our tools to drive the process. And so I'm going to start at the outermost layer of abstraction, which is this line here, line 12, in the feature file. So let's take a look at that feature file. This is a turnip RSpec feature. If you're not familiar with turnip, turnip allows you to use cucumber-like syntax. The details are not super specific. The general concept is that we write high-level, domain-specific language in our tests that maybe our clients can easily read, and they are executed in order. And we can see that if a particular line, which is called a step in turnip, fails, then the testing will report an error. So in our case, the failure was occurring on line 12 of this feature file. So we take a look at that line to see if there's any information that we can gather from that. I want to start with the most outer layer of abstraction and verify my assumptions as we go through. So looking at line 12 here, we can see that there's not enough information to determine why the error is occurring. So let's go back and look at our stack trace. Let's move one layer deeper, closer to our application code. That's line 32 in the spec steps file. And this is going to allow us to know where to index. So let's go look at the step definition on line 32 to see if we can determine any information from there. Here we are in our spec steps file. And the step that's failing here in line 32 is the line that we're interested in. This line references the internal state of the crab, and there's a key there, infection, and we're expecting that that key will possess some value, and that value will be equivalent to an instance of the parasite. So now we've narrowed down exactly where the error is occurring, but we don't know why. So let's take a step back. We're going to step up one level of abstraction again and determine where we should look next. Excuse me. So here's the feature file again. We know the failure is on line 12. So we can determine that where is the root cause. And we know that it's somewhere between lines 3 and 11. We don't know when the crab's payload should have, the infection value should be set, but we know it's somewhere between lines 3 and 11. So at this point, it's very tempting as a developer, it's very tempting for me personally, to want to go investigate the details of how the crab and how the parasite, the Saccharina carcini, is implemented. But that would be premature at this point. That would be making assumptions. This is a new code base. It's not necessarily a good idea to jump ahead. We need to validate each assumption that we make. We want to validate as we go so that we have a good foundation to know that when we find a root cause that we're very confident in it. One of the most challenging things in debugging is when you have one symptom, one failure, one error, one test case, maybe one report, but you have multiple causes that are colluding at the same time. So if we can validate our assumptions one by one, we're much more likely to discern a situation where there are two root causes that are affecting one symptom in our application. So we're going to allow our tool, our debugger, to drive the process. We're not making assumptions, we're going to stay assumption-free. So let's use the debugger. In this case, I've been using a generic term for debugger, but specifically we're going to use the debugger gem. There's two things we need to do to use this gem. We need to update our gem file with a reference to that library, and we need to add some code that tells the debugger to run when we're running our test. So the question is, the debugger is going to pause our application, and where should we pause it? We talked about that the error was probably the root cause is somewhere between lines 3 and 11. So in lines 3, they were the background steps. This is the setup for your turnip feature. In this case, taking a glance at these background steps, it's very easy to see there's not a lot of logic here. So the cause is probably not in this area of the application. There's no relationship being established between the crab and the parasite. I feel like that's a safe assumption to make. So instead, I think we need to drop it in the first step that's occurring in our feature, which is in, this is the step definition, and we're going to add it to line 10. This is the first place that the parasite, the Saccharina carcini, and the host are interacting. There's something interesting here that I need to point out at the beginning. I hate when I'm introducing a new topic or talking about basics of something and I have to add in exceptional information about edge case. But if you notice, we have here the debugger statement on line 10, followed by a semicolon, followed by the Ruby truce expression. The reason for this is that this particular Ruby library, the debugger library, pauses execution after the debugger method is called. If we do not have this true statement here, then, and the debugger method call is the last statement in another method, the debugger will actually pause us and stop the application outside of the context of that stack frame. So it's important that I add true as a default when I'm using this particular library, and that's how I use it, and that's how we explain it. But it's a little strange. So let's actually, now that we have our debugger statement in our feature file, let's go ahead and run a focus test. So here's our first introduction to the debugger session. And let's take a moment to look at what the different parts are and what information is being exposed. So first up, we have some context. The debugger is showing us some context in our application. If you've come from another language, Java, they have much stronger tooling support than the Ruby community. And so you may see, if you're using a debugger tool, you may be able to see your code executing, and you may be actually stepping through your application. In the command line tool here with this debugger library, we get to see the context. It's going to redisplay the code where we're at. And by default, we're getting 10 lines of context. On the left-hand side, we get a column that shows us which lines are being displayed. There are ways to navigate forward and backward through the current file if you are interested in doing that. And we can actually see what lines we are currently paused on. Now, what's interesting, again, remember, it's important to note that we're actually stopped on the semicolon. So the debugger method has executed, and we have not yet executed the true statement. And this hash rocket is what indicates what line we're actually paused on. It doesn't indicate which Ruby expression in the line if you have multiple expressions in the same line, but the hash rocket gives you a general idea of where you're at. So great, now we know where we're at in the debugger session. Let's examine the code, the rest of the code in this step. So we have 2 lines here. Line 12 looks interesting, doesn't it? If you remember earlier from the failure message, where we were expecting a Saccharina carcini, but we were receiving a nil, and it was related to the crab's payload with the infection key. So now, I want to know how that value is changing over time. There's a debugger command that we can use for that. It's called display, which I've abbreviated as DISP here. And I want to see what that value is as the code is executed. So we're going to execute this command. The debugger provides some feedback showing that the arbitrary Ruby expression that we've passed to the display command is currently nil. There's no value there yet. That's okay. We're still in the beginning of this test. And now we want to move forward. So to move forward in our test and execute further lines, we use a command called step. And I'm going to go ahead and execute step here. And what's interesting is not much changes. In fact, we've moved forward 1 line, but we know that we just executed the Ruby true statement. So one other thing to notice that has changed from the previous output, and you may have already noticed it on this slide, is that now we have a display variable for the crab's payload. And we will see that every time the prompt is redrawn, we will still see that information. This is also called a watch variable if you're familiar with from other languages. So executing true did not change the state of the displayed Ruby expression. That's a good thing. It would be nerve-wracking if something had happened. Somebody would be doing something very advanced and very well if that were to change the state. So we'll step again. Now we're currently on line 11, and we step again, and the first thing to note is that our arbitrary Ruby expression has not changed. Our display variable has not changed. But something has changed here. If you notice, the context has changed. We are seeing different lines. In fact, we're now in a different file. The step command goes into the method definition. We had a method call, Saccharina carcini was calling the attach method, and now we're inside the attach method inside of that class. We don't know the internals of this class, we don't know how it works, but now we're in here. We have now moved 1 layer of abstraction closer to the application. We're in the meat of the application, but I don't want to be here yet. It's too soon again. I like to validate everything that I can at 1 layer before going down deeper. So instead of boring you with the details, the internal implementation, I want to move forward and sort of skip past that, so I'm going to use the step command again. This time it's a little bit different. I've added the number 3 after the step command. The step command will take an optional argument that indicates how many times the step command should be executed. So this will execute step 3 times for us. If there are more method calls inside of this method, we would then step into those. So we're going to go and execute that, and it's going to take us back out into the layer of abstraction that I'm comfortable with right now, which is the step definition file. We are back in the step file, and we can verify that our arbitrary expression, nothing has changed. So in the internal execution of the Saccharina carcini's attach instance method, nothing had changed. We are in good shape. The error is probably not there, and so we can move forward. The and see what happens. Now we're on line 12, and we can see here on line 12 that the payload is actually being assigned. So we would expect this value to change, and we step forward, and sure enough, it does change. We do have a value here now. Due to the resolution size of my slides, you won't be able to see the exact location in memory that this instance lives at. You'll just see the first 4 or 5 characters, but I assure you that the value doesn't change. You just have to take my word for that. So we have a value for the payload. This is great. We know that at some point, somehow, our expectation at the end of the test is receiving a nil when it should receive a value. So that's the key thing that we're trying to stay on top of. So, but what's interesting, you may notice again that our context has changed. We finished this step and the turnup step, and we executed the debugger command step, and now we're in a new file, the turnup rspec file. This is a level deeper. Now we're in the Ruby library. We don't want to be here. It's very tempting. It was for me as a new developer to assume that my code was perfect and that the bug was probably in some library that I was using. But I assure you that that's never actually happened. It's never actually been in the library. It's almost always in my code. So it can be a little confusing when you're using the step command. Where we want to be again, we want to stay at this level of the turnup feature file. We want to get back to the step definition file and turnup feature file. So we really want to examine what's happening. We have the initial debugger command method call in the step definition of line 8. So we're really interested in what's happening between lines 8 through 12. So we really want to stop the execution at each step. And so we really want to stop it in the step definition file here. We want to stop it at lines 16, 20, 24, and 28. Now we know one way to do that already, and we've talked through it. We can use the debugger method call, followed by the true expression. And we could do that, and our code would look something like this. And that would work. But there's a better way to do that. I don't recommend this way. This is a contrived, arbitrary example, which is, on the whole, somewhat simple compared to the applications that you guys are working on day in and day out. If you try to manually specify when your application should stop in these types of, in regular applications, you'll find that you will litter your application with debugger statements. At that point, you're not too far away from using puts. My experience is that if you have a great test suite, you'll catch places where you forget to remove it. But if you don't have a great test suite, you can find yourself shipping code into production that has a debugger call, which will traditionally, would commonly break production because you usually don't have debugger gem installed in production. So let's make use of the tool that we have. There's actually an easier way to do this. We can create a breakpoint, and here I've used the short version. I've used the abbreviation B for break, and I want to drop a breakpoint on line 16. We want to drop one on line 20. 24, 28. And so if you notice the breakpoint syntax is B, which stands for break, followed by the file name, followed by a colon, and the line number. And the debugger library is giving us feedback and showing that these breakpoints have been created. One of the things to note about breakpoints in Ruby is that they will only be effective if it's on a line of Ruby code. If you create a breakpoint on a blank line, or you create a breakpoint on a comment line by accident, your application will not pause when it passes that point, because there's nothing to actually execute. So at this point, we've got our breakpoints in our application. We're in good shape, and we'd like to continue. We'd like to move forward. We'd like to resume the execution of the application. So we type in continue, which can also be abbreviated as C, and we move forward. Fantastic, we've hit our first breakpoint. In fact, the debugger tells us so. It tells us, hey, we're at breakpoint 1 on line 16 of the steps file. This is fantastic. We take a quick look at our displayed Ruby expression, and we see that the value hasn't changed. We still have a reference to an instance variable. This is great stuff so far. And now we're on line 16, right? And we see that there's a new method being called here called shed. I don't want to dive into that layer of abstraction again, so that we continue again. We continue, and then the debugger will stop us at the second breakpoint, line 20. Take a quick look at our displayed Ruby expression. Value has not changed. We're good. Now that you guys are comfortable with continuing, I use the C and we can move forward. We hit breakpoint 3, again, the value hasn't changed. We're progressing through and we're passing, who knows how much code is being executed that we're skipping over by jumping from breakpoint to breakpoint. We could step through each Ruby expression in each of those steps and dive down and see what's going on, but that's not an effective use of our time. I like to use sometimes I'll use a binary approach where I will look at the range of where I expect the error to occur and maybe start and drop a debugger expression in the middle, and then attempt to validate the state and my expectations at that point in the application. So what we're doing here is we're jumping over large swaths of code. We don't even know how much code is being executed, but what we have verified is that we still have the same value. We're in good shape. So we continue to go forward, and now we've hit breakpoint number 4, which, if you remember in our feature file, is actually the last step, turn-up step. And we are currently paused on line 28, and our value of our Ruby watch variable, the display variable, hasn't changed. So we've eliminated 75% of the lines in our turn-up feature file as being likely culprits for this error. This is great news. We're sitting here, we have a new method. So the last time we were sitting in a method that we used the step method. And we took a detour that I didn't have to show you how to get out of passing in step 3. And we don't want to do that again. Again, if I can stay at this level and see what's happening, that's fantastic. So let's explore another debugger command. This is the next command. And the next command, instead of stepping into the method, will step over the method. So it will actually internally inside of the debugger library, stepping into the method and executing until that stack frame has completed and popped off of the stack, and then repauses the application. So we type in next, we hit enter, and here we are. The hash rocket shows us that we're on line 29, and we've executed the crab's external method, and we can verify again that the value hasn't changed. We still have our value here. It hasn't been replaced by nil. So what that leads us to believe is that the bug is not in any of the code that we have seen or executed so far. Much faster than stepping through and trying to manually execute what's occurring. I don't know if you guys have noticed what the error is, but it's on this page now. We can see actually what happened. The developer, the preceding developer, made a mistake, and this is a common mistake. I've made this numerous times. We dereferenced the payload via a symbol in one place versus a string in another. This is not a hash with a different access by default. I love Rails. I do a lot of Rails development day in and day out, but it tends to lead me into a false sense of security regarding hashes, because by default in Rails, most hashes have hash with a different access. So you can reference your values via strings or symbols, but when you're not in Rails and you're in pure Ruby, that's not often the case. So this is the error that occurred here, we think, anyway. This is our hypothesis. We developed a nice hypothesis that this is probably the cause. So we can actually exit our debugger at this point, and we can use the quit command, which may also be abbreviated as Q. And then make sure we're absolutely sure we're going to quit. I think of software that asks for confirmation like this as insecure software. Yes, we're confident in our decisions. All right, so now let's go back to our code. We have a hypothesis that it is in one place we're using a string, in another place we're using a symbol. So let's make the code changes. We're going to change our code here from a string to a symbol, and then we're going to remove our debugger method call along with true, so that we can just run our focus test and see if it passes. This is how the code looks after that point. So we run our test suite. Success! This is excellent. We've got a great test suite. We can move forward. All right, so that was a gentle introduction to using the debugger in Ruby. Let's do a quick recap of what we covered. We covered the debugger method call, right? It has to be, in general, you want to use semicolon true afterwards. We covered the display, which allows us to examine arbitrary Ruby expressions. We can abbreviate that with DISP. We covered the step method. The step method can receive an arbitrary argument that indicates how many times it should be executed. We covered the break command, and specifically, we covered the break one format, one version, and we covered this version here, right? We type in break with the file name followed by the line number, which can also be abbreviated as B. But there's a few other ways to use it. You can also give it a method name. In this case, you can give it a class method name, and the debugger will pause on that once that class method is executed. You can also do instance methods, and I didn't have any slides up here that display this, but you can also pass in an arbitrary expression that must evaluate to true after the line number or the method name, if you would like to do that. Then we covered the continue, which resumes the application, and it will continue until we reach another breakpoint or the application completes or an exception is generated. And then we covered next, which allows us to step over a method, but yet still execute it. And it is, again, you can use next with an arbitrary number following it to indicate how many times it should be executed. And you can also abbreviate it as N. So fantastic. You guys can go forth now and debug with great skill. But there's a couple of things I didn't cover in our case study that I think are super important, that I think that you should know before you walk out of this room. Finish is another command that's useful. Finish is nice. We could have used it in this demo, but we didn't. So if you remember when we stepped into the attach method, that we were in a lower level of, we were in a finer detail level of abstraction that we weren't interested in. If you find yourself doing this, we use step 3 at that time. But if we had a loop, maybe you're iterating over thousands or tens of thousands of things, maybe your breakpoint is inside of your loop, and you hit that breakpoint when you hit the 50th item in your collection. And you want to evaluate the state at that point, but you're not worried about the other 950 items in the collection. You can then hit finish, and the finish command will then execute until it completes that stack, until that stack frame completes, and then execution will be again paused. And so in this case, if we type in finish and then we hit enter, and we're inside the attach method, we are again paused on line 12 of our step definition. So the other command that we didn't cover, and this is actually my favorite one, and I find most useful, most valuable, is the source command. With the source command, you can pass it in, it takes an arbitrary file name as an argument, and that file should contain valid debugger commands. And it will execute those valid debugger commands and those will contain things like displaying Ruby expressions, maybe variables that you're interested in. Maybe you want to only see when the variable change, so you use some type of equality condition. It also contains breakpoints. It can contain breakpoints. Anything that's a valid debugger command can be contained in the source file. I manually, when I'm debugging a very complex application that has tight coupling between the data and the logic, and a lot of branches, a lot of possibilities in different ways the code may go, then I will use this to retain my debugging session state. Because it's very possible that I will be inside of the application and I will change and modify the state, and the modifications that I make, that I'm using to help me diagnose the root cause and find out where that application is going wrong, where the error is occurring, may then preclude the error from occurring. So I'm doing investigative, exploratory things. But if I save my debugging session and I have maybe 5 or 6 breakpoints and 5 or 6 displays variables in a specific file, then I can easily restart my application, source that file, and have that same state again very quickly. So this makes me very efficient when I'm debugging. Now there is an analog to source that I did not talk about called save, that will save out the current debugging state. Unfortunately, in the debugger library, it does not save your display variables, it only saves your breakpoints, so I avoid it for that reason. And here's an example of what a source file could look like. And this would be, we could have used this if we had to rerun our feature file again a few times to do maybe more investigative work. So what else did we miss? There's something really important that we missed here, and if you've ever tried to use any of the debugging libraries in Ruby, you probably already asked this question, at least to yourself, if not to your neighbor. Which version of Ruby am I talking about? All the examples we've seen so far has been with Ruby 193, patch level 392. Which version of Ruby you're using dictates which Ruby debugging library you will use. I've got a nice matrix of information here for you that contains which ones you would like to use, that you should use. If you're still using Ruby 1.8, you'll want to use a library called Ruby-debug. When Ruby 1.9 came out, Ruby-debug 1.9 was created for that reason. It's since been superseded by Debugger, which is the one that we use. And there's also Debugger 2, which is a fork of Debugger. We'll talk a little bit more about that in a second. And then if you're using Ruby 2.0, you can use Debugger, or you can use something called, you can use Debugger 2, or you can use something called bypass. So, real quick, I'm saying that debuggers stink, and you may ask, why am I throwing a slide up here? I just want to be provocative. Debuggers don't stink, I actually love them. But one of the things that's been challenging in Ruby, and this is the change log for the debugger gem that we were using in our example, is that version bumps have occurred not in sync, actually there's a little bit of a lag, a little bit of a gap, but with the Ruby source. And the reason for that is that the debugger library needs to have internal knowledge of the Ruby's header files. So as the Ruby internals change, the debugger needs to be updated. This leads to a very frustrating gap where a new patch level has been released in the version of Ruby you're using, or maybe a new point version is released, and there are no debugging tools for a short period of time. This is due to the Ruby C API. It can be very frustrating when you're trying to stay on the bleeding edge and keep up to date with what's occurring. But some progress has been made in Ruby 2.0. The Ruby source code maintainers have focused on a specific API, and they've exposed that, and they've promised that that won't change. So the later debugging versions for Ruby 2.0 are trying to make use of that. So hopefully we won't be in quite such a bad state going forward. So if you're going to use Ruby 1.8 real quick, you will want to set a couple of default options in your rdebugger. This is auto reload, auto eval, auto list. This will give you the behavior that you've seen in this case study from earlier. Later versions in Ruby 1.9, and that includes debugger, bybug, debugger 2. These are the defaults. You don't have to set these manually. So there's been that lag time. If you're using 1.9 again, use debugger, debugger 2, Ruby-debug 1.9 you can use if you want. I don't recommend it. It's because it's been superseded. And then again, on 2.0, you're going to use debugger, debugger 2 or bybug, excuse me. So I'm getting short on time, I'm speeding up a little bit because I want to cover a couple more things. Pry, if you've kept up with this space, you might have heard about Pry, and you're asking, why hasn't he spoken of debugging and with Pry as part of that context? It's because Pry is not a debugger. If you look closely at the last page, the screenshot of the Pry homepage, you'll see information like Pry is an alternative to IRB. It's not a debugger. It's actually a REPL, which stands for read eval print loop. But it has some really cool features that make it very nice to use. It has syntax highlighting. It has a flexible plugin architecture. That's key because that allows us to use Pry with other debugging libraries. So if you want to use Pry to do debugging functionality, which includes next step, continue, finish, break, then you can. And it's very simple to do. You drop into your code, you reference Pry, and you use a tool called Pry Debugger. This is an extension to Pry that uses the debugging tool that we already spoke about. But even though it's using that underlying debugging tool, its interface is a little bit different. Instead of using debugger semicolon true, we use binding.pry. So we're going to go ahead and run our features. We want to see what that looks like. We see that execution is stopped. It's a little prettier now. We've got colors, right? But other things are still similar. You can see that we've got the hash mark that indicates which line we're on. We can see which file we're in. So we're going to step forward. And it's nice to see that we don't require that true again because the binding.pry stops before the execution of that. So we step forward, we're on line 11, we can use next, that works. But here's a case where it's a little bit different if you're going to use Pry. We have the break command. It's a little bit hard to see on the right-hand side of the slide, but it's break, there's no abbreviation. It's not available in Pry by default. And then we have to specify the relative path to our project directory, followed by a semicolon, followed by the line number. So we can't just say the steps.rb. So no shortcuts. You have to specify the full path. You can use, I believe, the instance method and the class method of the break command. And what's interesting is after we've done that, we get information about the break command, and we actually want to move forward. And what's another thing that's interesting to note is it's actually, instead of giving us context about where we're currently at, it's giving us context about where that breakpoint lives. This will allow you to see if you accidentally set a breakpoint on the wrong line, if it was on a comment or whatever, it will show you that context. so we're going to continue, and one more cool thing that it does, it actually shows you a breakpoint, and I'll show you how many times it's been hit, which is neat. So a few more things to know about Pry. If you do want to use the aliases, you get the shortcut commands, you can do so. You just have to set up, add some information to an RC file, and that information is available on the Pry Debugger website. So Ruby 1.9, you can use Pry plus Pry Debugger if you want. So the last debugging library I wanted to touch on really quickly because it's very interesting is Bybug. Bybug was just created in the last couple of months, and it was created because of existing open issues in Debugger and Debugger 2. Debugger 2 was a fork of Debugger by Koichi Asada, one of the maintainers of Ruby, and he created Debugger 2 to work with Ruby 2.0 using the defined C API, but there's still some open issues, so it's still a work in progress. The developer for Bybug was frustrated, needed to use the debugger, so he took a mashup of Debase, which is another Ruby debugger we did not touch on, and the debugger library that we used in this presentation, and sort of smushed them together. He took the XP extension part from one and the library test directories from another. And so you might ask, why should we use Bybug? Well, it works on 2.0. There's much less issues. There's much less open issues. It works the exact same as the commands we covered in the debugger, which is why I use the debugger library today in our case study. You can see some of the things that are different here if you want to check out. Ruby 2.0 supports the most important thing. It actually fixes, if you're interested in your backtrace, you can't get that. It wasn't working in debugger last I checked. So what else? What other debuggers are there for other versions of Ruby? So far we've been focused on MRI. For Rubinius, there is a debugger that's built into Rubinius. If you're going to use that, you can call Rubinius ::debugger to start. It's very similar to using binding.pry. And it has similar commands that we've covered. Maybe the syntax is a little bit different, but it's featureful. You can use that. For JRuby, I've looked into using debuggers for JRuby before, and you have a plethora of tools that are available, just tons of tools that are available because you're on the JVM and you can use those. So, quick overview. We did a case study. We talked about the basics. We looked at a couple of advanced commands, my favorite being source. These tools allow me to be much more efficient in deciphering where the root cause of errors occur. Then we looked at the debugging libraries. If you're on 1.8, use ruby-debug. If you're on 1.9, you can use debugger or you can use Pry plus debugger. If you're on 2.0, I recommend using Bybug. And you can also use Pry, and there's a Pry extension to use Bybug inside of Pry as well. So that's my talk. If you want to see the slides, they're already up on SpeakerDeck. The code that we worked with today is available on my GitHub account. The image I borrowed from Flickr, so kudos to the person there who shared that image with us. If you want to know more about me, I've got a blog. You can check it out. You got my email address, Twitter account, and I want to give a big thanks to the organizers for this conference. So happy to be here. I also want to thank Big Bear Ranch for my company where I work that sponsored for me to come out here and give you guys this talk and share this information. So thank you.
We have 8 minutes for Q&A.
Do we have 8 minutes for questions?
Great talk, Jonathan. Coming from a statically typed library like Java, Scala, .NET, we have these tools built into our IDE, so we can just do F5 or click on a button. So with RubyMine, is if you know if it is the debugger support there, or I have to fall back to the command line?
The debugger support for most of the IDEs, I've not used them, but I've had colleagues that have. So the question was, what about other IDEs? Statically typed languages have fantastic debugging support built into the IDE. What about Ruby? So there are tools like RubyMine. There's a few others that names escape me off the top of my head. Yes, they often have debugger support built in. I don't necessarily know if they're using this library or their own debugging library, but they're very, very awesome. They're very impressive. I've been using them for 15 years. That's my comfort zone. I'm not going anywhere. I've yet to find an IDE that has sold me yet. So. Good question.
Any Rails specific tips for debugging?
I'm sorry?
Any specific tips for debugging in Rails?
Debugging in Rails. That's actually where I do most of my debugging. I would say that there's one of the things we didn't cover today is that you can use Foreman. I think a common pattern is to use Foreman to start up your Rails server along with any external services that are required. And In that case, you might find that it's difficult to have access to the debugger. So there's remote debugging tools, and you have something called Ply Remote. I don't like Foreman, so I try to avoid it. And even with projects that use it, I will often start those individual services individually myself. I like that finer-grained control, and that's why I like Vim or IDEs. So the general things that we've discussed here: be focused about what you're trying to debug. Use breakpoints, and yeah, I think the same general principles apply. So nothing specific other than that there are tools that allow you to attach to the debugger remotely if you are using a tool like Foreman.
Excuse me.
You already mentioned a bit about remote debugging. If you have any special tips about remote debugging, or how can we attach a debugger instance to a running instance of program?
I'm sorry?
About remote debugging, and if it's possible to attach a debugger to a running instance of a program.
Yeah, so if I got the question right, you're asking, can you attach the debugger to a running Ruby process? Is that correct? Okay, great question. Yes, you can. Actually, a few years ago, there was a really cool library called Hijack that was released, and Hijack was nifty because you could inject debugging capabilities into an existing Ruby application that did not have the debugger associated with it. So before gem files were common, you could run Hijack and attach to maybe your production environment, and then have debugging capabilities inside your production environment. I think this is a last resort for really tricky problems. And generally, just restart it, right? Just restart your Rails application or whatever. But so yeah, you do have ways to do that. I haven't looked at it in many years, so I'm not sure if it still works at all. But yeah, you can do things like that. There's flexibility to do that. So interesting.
We can take only one more question right now. Others can catch up with Jonathan after maybe at lunchtime.
Yes, actually a couple of questions. First is, what happens with threads? I mean, are all the threads paused, or is just the thread in which you have inserted the breakpoint? And the second is, do any of these comply to like the GDB external interface, so you can attach other UI tools that work with GDB?
So 2 questions. One is, can you attach external tools like GDB? And the other part of the question was, what happens when in a multi-threaded environment? I was joking about this last night, that if you're writing multi-threaded code in Ruby and MRI, why? And if you noted on the slide that talked about Bybug, it doesn't support multi-threaded debugging. And most of these don't. So the state of the debugger land is still even after these many years, is still very rough. So if you're using multi-threaded programming in MRI, good luck. Maybe you switch to using some type of actor approach, some type of library there. And yes, you can attach DDB to a running Ruby process. You can use Java tools if you're using JRuby. If you're fortunate enough to not have C extensions that your application relies on, you can attach Java. I did a talk a few years ago on debugging memory leaks in Ruby, and again, the tool set is not very robust and very far along. So I actually ended up switching over to the JVM for my talk, and there were some really nice tools that allowed me to examine the state of the memory application in a multi-threaded environment and examine what's going on. So you can do that, but in MRI, it's going to be one of